So problem number 16 is asking us to find which is the best choice for evaluating the integral square root of 4x squared minus 1. So when I look at my 5 options, 4 of them are trig substitution and the other is factor 4x squared minus 1. So if I factor 4x squared minus 1, I end up getting 2x minus 1 and 2x plus 1. However, it's not a perfect square, so therefore if I try to factor this, I'm just going to end up with 2 terms underneath the square root. So letter B doesn't look like the right answer in this case. So I'm left with the other 4. So if the other 4 want me to do some kind of trig substitution, I need to look at the form here and figure out which trig sub it matches. So in this case, it looks like I have an x squared minus a squared. So I have some function of x squared minus a constant squared. When I have this form, my substitution should always be x equals a secant of theta. When I do this, I end up getting a squared secant squared theta minus 1. If I pull out the a squared from both of those terms, secant squared theta minus 1 has a definition as a trig identity, and that's equal to tangent squared. So that would be the substitution that I would want to plug in to be able to get this. So now, if I look at my answers, the only one that has secant is letter D. Letter D says that 2x should be equal to secant theta. So when I actually plug that in, I could end up getting secant squared minus 1, which reduced to tangent squared. I could take the square root of tangent squared by itself and just get tangent, and I can integrate it from there. So the answer in this case, letter D. That is the best option for integrating this.
The Teaching Center, UF's Learning Resource Center.